Okay, this video is going to talk about special products of polynomials. Specifically, we will be looking at a binomial times a binomial, and we're looking at situations where we've got a special pattern that comes about that if we recognize that special pattern in the future, we could get to the answer faster than multiplying out the normal way. So if you're not sure how to multiply polynomials in general, I recommend you stop and go back to the video I posted previously on that topic that is entitled Multiplying Polynomials 10.2 because this video assumes that you already know how to do that. We can either use the distributive property or FOIL, whichever way you choose to use it. It's just a matter of how you're thinking about it. You actually are doing the same exact thing either way. So here we have x plus 7 times x minus 7. We're going to multiply this out, and we're going to see a couple more problems that are similar to it, and then I'm going to talk to you about what the pattern is that we should be noticing that then we can use on future problems if we recognize that it's this type of problem. So when we multiply these together, we need to do x times x, which is x squared. Then we're going to do x times negative 7, which is negative 7x. Then we're going to do 7 and x together, which is positive 7x. And then 7 times negative 7 is negative 49. When we multiply polynomials together like this, we check for like terms. So because the middle terms both have an x, these are like terms. Negative 7x plus 7x is 0x, or in other words, these cancel each other out, because if I have negative of something and positive of that same something, it basically just goes away, in math at least. And so this leaves us with an answer of x squared minus 49. For some of us, this may be enough to recognize the pattern, but what I'm going to go ahead and do is write down the problem and the answer and leave it up so that we can compare it on the next problem, and that's going to help us find the pattern, because really all these math problems have to do with patterns, and what happens is a lot of times your teacher just tells you what the pattern is without letting you discover it yourself. Now, we could argue all day long about whether or not you should be allowed to just discover patterns on your own. There are definitely times where that is a frustrating experience to be a part of, and so a lot of times we go ahead and help you find the pattern. I try to explain why the pattern works the way it is with most things, but this in particular, I think, is a pattern you can actually discover for yourself. So we're gonna just pretend like we don't know what's going on with the pattern here. If you've already spotted it, that's great. We're gonna do 8n times 8n, which is 64n squared. We're gonna do 8n times negative 1, which is negative 8n. 1 times 8n, which is positive 8n. And 1 times negative 1, which is negative 1. When I look for my like terms in the middle, I have negative 8n plus 8n, which is 0n, which cancels out. Interesting. That's the same thing that happened to us just a moment ago. So hopefully at this point you're like, okay, I can tell that something is happening here. The same thing happened to me twice, that the middle term canceled out. You may not know why that's happening, but if you could recognize just that something was happening, that's actually part of the process here. So let's think about why that might be happening. So in both of these cases, we don't have a term with just x or just n because it canceled out. So let's look back at the original problem and see if we can make a connection that might make sense. So think about that as I go through problem number 3. If you think you've got it, then try number 3 on your own to see if you've got the hang of what the pattern is. So I'm going to assume if you wanted to work it on your own, you've paused the video, so I'll keep going. 3k times 3k gives us 9k squared. My outer term here is 3k times 2, which is 6k. My inside term, negative 2 times 3k, is negative 6k. And my last term, negative 2 and 2, is negative 4. So I look at my middle terms, they're like terms, and again, they cancel each other out. So the pattern definitely seems to be that my middle term is canceling out. But the question is why? Like, what should we recognize about the start of the problem that would make that happen? If you have not recently done just a whole bunch of problems like this, It doesn't normally happen. It's not just going to happen all the time. The middle terms cancel out. A very specific thing is happening here. So let's look and see if we can figure out what's the connection on all of these starting problems that we could make that might tell us when we can use this idea of the middle term canceling out. And this is where I pause to see if you answer back, like whenever you watch like Blue's Clues or something like that. That's right. What is happening here is that we have the same thing in each parentheses, but one has a plus sign and one has a minus sign. It doesn't matter which one is plus and which one is minus. For instance, here it's reversed. The minus came first and then the plus was second. All that matters is that the parentheses are identical except that they have different signs. We call this pattern the difference of squares pattern. Difference, I guess, of two squares. And so we're not talking about squares like the shape. We're talking about the fact that here is a square, x squared, and here is a square, it's 7 squared, and difference means subtract. So if we recognize that our parentheses are the same but with opposite signs, we can just jump right ahead to squaring each of our terms, squaring the x, squaring the 7, and then writing it as a difference. The only thing that I would say is an easy mistake to make with this pattern is when you're looking at this part right here, sometimes we'll forget to square the 8 as well as the n. So we have to do 8 squared is 64 and n squared, which is n squared. Another way of thinking of it, if you like the FOIL method, is to say, well, if it's the difference of two squares, I just need to do the f and the l for FOIL, because the outer and inner terms should cancel. So instead of foiling, we're actually flaing, which is a little bit simpler. Let's verify that we have got the hang of this. I think I have a fourth one of these. Let's go ahead and verify that we've got the hang of this. So if you have not already, pause the video, see if you can come up with the right answer, and then start it back. So the right answer here is 16 minus 4n squared, because 4 times 4 is 16, or in other words, 4 squared is 16, and 2n times negative 2n is negative 4n squared. The outer and inner terms, this part and this part, cancel each other out, so this is our answer. So that is one of our patterns that we have. There are two more, or actually you can think of it like it's just one more. And it is different. It's a pattern that's harder to see and harder to use. So keep in mind that you don't have to use these patterns. You are welcome to just multiply things out and get the answer that way. Like you can always just FOIL or distributive property this if you didn't recognize that you could use that shortcut, and that would be totally fine. Let's explore the next pattern. Hopefully that's this. Yep. So this pattern looks very differently. I think seeing that what's happening is easier on this one, like that the start, that all of these problems that we have are going to be something squared. So that part I think is the easier part to see, that our pattern comes from squaring a parentheses. What is harder to see is what happens when we square. If you right now want to write down the answer or guess the answer, if you guess 25 plus 49a squared, you are close and yet so far. Because what happens here is it's more complicated than just squaring these, because we've got addition in the middle. If this was multiplication in the middle, yes, we could square both of them. That's actually a property that you learn earlier in the year in Algebra 1, that you can kind of distribute the squared, but that only works if this is a multiplication symbol and it's not. What this is actually asking us to do is it's asking us to do 5 plus 7a times 5 plus 7a. And that's because that's what it means to square something. 5 squared means do 5 times 5. So we have something that's not just a number squared. We're still going to think of it like we're multiplying it together twice. So let's go ahead and multiply this out. We've got 5 times 5, which is 25. That part was right. And then we're going to do 5 times 7a, which is 35a. And then we're going to do 7a times 5, which is 35a again. And then 7a times 7a, which is 49a squared. So what's happening here we've got two parts. We were able, if we guessed this, we were able to guess pretty well. Or if we didn't guess, then never mind. But the middle terms here do not cancel each other out because they have the same sign. We do positive 35a plus 35a again. Together that makes 70a. So our answer is 25, which we thought it would be, plus 70a plus 49a squared. So the pattern that's happening, we should be able to really easily get this part and this part. The question is, how can we get 70a from these two things without actually just multiplying the whole problem out? This is a case where the pattern may not actually be faster than just writing it out and multiplying it twice, and that's fine. You don't actually have to use the pattern here. No one can actually make you use the pattern. It does help us, though, to try to use them at this point in our math career, because later on we'll learn patterns that save a huge amount of time. And we'll actually learn some patterns that basically there's not another way to do it, or not another easy way to do it, except to use the pattern. So we're kind of preparing for that with this pattern that we don't actually need to use, but as far as patterns go, it's a little bit easier than some. Let me erase. If I was a mean person, I would leave just like that speck there for all of you OCD people watching this video, but I'm not mean, so let's look at the next problem. Okay, so I said that we had two more patterns, and that's actually because some people write the pattern differently when we have a minus instead of a plus, but really you can think of it the same sort of way. So we know that we should have 5 times 5, which is 25. And we know that we should have 6x times 6x, which is 36x squared. And since we'd have negative 6x times negative 6x, that'd be a plus. So the question is, what should our middle term be? So I'm going to write out the parentheses twice. We've already done 5 times 5 and negative 6x times negative 6x. So now we just need to do 5 times negative 6x, which is negative 30x, and negative 6x times 5, which is negative 30x again. When we add those together, we're adding two negative 30x's together. So in other words, we could think of it like multiplication, I suppose. 2 times negative 30x, which is negative 60x. That's our middle term. I'm trying to guide you to a way of thinking of how to get this middle term without actually saying it outright yet, because I want you to have a chance to discover it for yourself if that's something that you are interested in doing. So notice that we have a minus sign right here, where before we had a plus sign, and that had to do with this minus sign that was here. That's an important part of this pattern. Let's do another one. All right, 8x minus 4 squared. So again, we know part of this, right? Wait, there we go. We know that 8x times 8x is going to give us 64x squared. We know that negative 4 times negative 4 is positive 16. The question is, what is that middle term? So if I just do, and you even actually can save yourself some writing and write this out to the side like this. If we do 8x times negative 4, we get negative 32x. But wait, 8x times negative 4, I didn't even really need to write that again because I have 8x and negative 4 right here. I guess I could think of this like I'm multiplying these together, but I'm doing that twice. So what's twice as much as 8x times negative 4? That would be negative 64x. Okay, so maybe now we're coming up with a way of thinking of that middle term. I'll actually go ahead, I guess, and write out how you might see the pattern in a book. And maybe that will help some of us who have not yet understood how this is working. So what they'll do in a math book is they will write a minus b or a plus b, depending on whether it's a plus or a minus in the middle. And then they'll say that's going to equal a squared minus 2ab plus b squared. So how this works is that in this problem, 8x is A and 4 is B. And so if we fill that in here, and we fill the 8x here, and we fill the B here and here, if we do this, we should get the answer. So 8x squared, remember you have to square the 8 as well as the x's, 64x squared. This is 3 things to do together. We need to do 2 times 8 times 4, which is, if you do it, 2 times 4 is 8, and then 8 times 8 is 64. That's minus 64x. 4 squared is 16. We get the same answer, right? So the reason I'm addressing that is this right here is the part that's the difficult thing to use in this pattern. The idea that we want to do twice as much as these 2 things multiplied together. So if you can get that and remember that, then that will help you to be able to do this faster. Again, I mean, at this point in math, if you're taking Algebra 1 right now for the first time, it may be really difficult to use the patterns. It may not be the easiest way to go. So don't forget, you can just multiply it out. Just make sure you don't forget the middle term. So if I want to just use the pattern, not show any work, then what I would do is say I'm going to square this and get 16x squared. I'm going to square this and get 64. I'm going to multiply these together and then double it. So 4x times 8 is 32x, and then times 2 is 64x. And because it's a plus in the middle, that's a plus in the middle. So here's my answer right here. I feel like I had a lot of the same numbers used, like we just did 8 and 4, so that's inconvenient. But that pattern will hold for any time you have a parentheses that is squared where you've got a binomial inside. So something plus something or something minus something. So the trick is now to be able to see problems like this in the middle of other problems. Like sometimes your teacher will put a special section, I guess, that just has these types of problems for you, and it even tell you that that's what you want to do as a special product pattern. But a lot of times we just put them in with other things to see if you notice it. So if you notice it, use it. This one is called perfect square something, I don't know, something about a perfect square. I feel bad. I should really know this. This pattern has a name, perfect square product or something like that. I'll put it in the description in case that's relevant. But this pattern also has a name if you are doing your math and you see a particular name used, but it has to do with the fact that we are squaring something. So this is a perfect square, maybe perfect square trinomial. We get a trinomial, so perfect square trinomial. Thanks for watching, and I hope you enjoyed discovering something instead of just being told what it was. And I wish you the best of luck on all of your math endeavors.
If you like this video, please hit the thumbs up and feel free to check out other videos. I've suggested one somewhere on the screen. If you want to know when I post new videos, hit the subscribe button, and you can also follow me on Twitter at KSteveMath. If you have a math question that I haven't answered, tweet me a picture and I'll try to answer it. Thanks for watching.